everyone. In this video, you're going to learn about the end behavior or how to determine the end behavior of rational functions. So we've learned previously that the end behavior of a function is the value that y is approaching as x approaches positive or negative infinity. So in our example here, we're looking at the graph of a rational function. The function is actually 4x plus 1 divided by 2x plus 1. And you can tell that the graph has a horizontal asymptote at y equals 2. Well, there is a relationship between the horizontal asymptote and the end behavior of a rational function. So what I wanted you to notice here is, if we look at the end behavior, so let's start with as x approaches negative infinity. Notice that the y values are approaching 2. Okay, let's go to the other side. As x approaches infinity, so now we're looking at this end of the graph, y is also approaching 2. Now, you can look at this a couple different ways. Based on the end behavior of the graph, we know y equals 2 is a horizontal asymptote for the graph of this rational function, or we could flip that around and say, because this graph has a horizontal asymptote, which is y equals 2, we know that the end behavior, meaning as x approaches negative infinity, y approaches 2, and as x approaches infinity, y approaches 2. Here's the main point. The end behavior for the graph of a rational function is determined by the horizontal asymptote. Okay, so you just want to put those two concepts together in your head. End behavior of a rational function, if you're ever asked to find it, you want to determine the horizontal asymptote. Okay, so how do we do that if we're not given a graph, but we're just given an equation? There is an easy way to determine the horizontal asymptote when you're given an equation. All you have to do is compare the degree of the numerator to the degree of the denominator. Now, remember, the degree of a polynomial is the biggest exponent. And since a rational function is the quotient of two polynomials, you're basically just comparing the biggest exponent in the numerator to the biggest exponent in the denominator. Now, there are three things that can happen when you compare the degrees. If the degree of the denominator is bigger than the degree of the numerator, then the horizontal asymptote is the x-axis. Now, the equation that represents the x-axis is y equals 0. Okay, so the HA would be y equals 0. All right, another possibility is that the degree of the numerator is bigger than the degree of the denominator. In that case, there is no horizontal asymptote. Okay? Now, there is another possibility that can happen that I'll show you later. The third scenario is that the degrees are the same. When the degrees are the same, the horizontal asymptote equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So basically, your HA will be the ratio of the leading coefficients in that case. Okay, let's look at some examples. List the horizontal asymptotes of the following functions. Example 1, f of x equals 3x minus 6 divided by 5 minus 2x. So all we have to do is compare the degrees. Both of these polynomials are linear, so the degree is 1. And the degrees are the same top and bottom. So that means that the horizontal asymptote is the quotient of the leading coefficients. So 3 divided by negative 2. Or, of course, you could write it as y equals negative 3/2. That is the equation of the horizontal asymptote. All right, let's look at example 2. G of x equals x divided by x squared minus 4. The degree of the numerator is 1. The degree of the denominator is 2. When the degree of the denominator is bigger, your horizontal asymptote is automatically y equals 0, which is the x-axis. Okay, and then in the third example, h of x equals 2x to the 4th minus x divided by x cubed plus 1. The degree of the numerator is 4. The degree of the denominator is 3. Since the degree of the numerator is bigger, there is no horizontal asymptote. Now, what that means about the end behavior is that means that y is either approaching infinity or y is approaching negative infinity instead of approaching an HA. Okay, there is one more scenario that can happen when the degree of the numerator is bigger. And that is called a slant asymptote. So the graph of a rational function has a slant asymptote if the degree of the numerator is bigger than the degree of the denominator by exactly 1 degree. Okay? To find the slant asymptote, you divide the numerator by the denominator and keep only the quotient. The equation of the slant asymptote will be in the form y equals mx plus b, which is slope-intercept form. Okay, so here's an example. Find the slant asymptote of f of x, which equals x squared minus x minus 2 divided by x minus 5. So to find the slant asymptote, we basically have to divide the polynomials. Now, you could always do long division, or in this case, we could actually do synthetic division, since we're dividing by x minus 5. To me, synthetic division would be the quicker way. Okay, so to set up my synthetic division, since I'm dividing by x minus 5, I'm going to flip that sign. Okay, then I'm going to list the coefficients of the numerator. So 1, negative 1, negative 2. You always bring down that first number, and then we multiply. 1 times 5 is 5. Then you add straight down. Then you multiply. 4 times 5 is 20. Then you add straight down. Now remember, the last number is the remainder. So 18 is the remainder. But in this case, we're really only interested in the quotient. And so the quotient would be 1x plus 4. So your slant asymptote is y equals 1x plus 4, or of course you could just write it as y equals x plus 4. So this is the slant asymptote. If we were sketching the graph, which we will do eventually, you would just have to graph that line. So the y-intercept is 4. You could start at 4 on the y-axis, and it has a slope of 1. So then you would just go up 1, right 1 to find another point, and then you could sketch the line. All right, let's look at one more example of finding a slant asymptote. So this time the function is x squared minus x minus 6 divided by x plus 4. Again, we can use synthetic division since we're dividing by x plus 4. But if you want to flip that sign, I'm going to make it a negative 4. All right, then I'm going to list the coefficients of the numerator. So 1, negative 1, negative 6. Draw a line, leaving a space. Bring down the first number. Multiply. 1 times negative 4 is negative 4. Add straight down. Multiply. Negative 5 times negative 4 is 20. Add straight down. Remember, the last number is the remainder. We are only interested in the quotient, which would end up being x minus 5, meaning our slant asymptote is y equals x minus 5. Okay, So that really concludes the video. We will definitely practice this in class, but it's also a good idea to study these 3 rules, okay, because you'll want to remember these. And as always, thank you for watching and have a good night.